first news item for today is, well, it's got to do with a 3D printing pen, but used in a way that you are probably not familiar with it. This is research by Dan Li, Zhang Ding, and Lianhe Wang about a extracellular vehicle ink we use in a 3D printing pen. The idea is to use a 3D printing pen to in situ on top of a wound on, for example, skin, apply directly a material that is like promotes wound healing, promotes quicker wound healing generally, and creates vascular or promotes vascular regeneration. They call this stuff paint, portable bioactive ink for tissue healing paint, and essentially it's got a gel, right? That that sets within 3 minutes. So it allows you to mix the material and then go inside a patient or on top of a wound and apply this with the 3D printing pen. So this is something I've talked about a bunch of times. This idea of bioprinting pens to deposit tissue or to deposit medicine really locally. If you think about it, for a lot of bioprinting applications and a lot of medical applications, printing an item and then afterwards putting it in the person is kind of cumbersome. And this could be very well be a paradigm of doing this for applying things for cosmetic stuff, but also applying things to wounds and skin and to promote skin healing and to promote wound healing and stuff like that. This was published at ACS, and I think there'll be a lot more work like it. The next news item is from Firestorm and Greenjets. Firestorm Labs is a company making UAS drones, and Greenjets is an electric propulsion engine specialist. And what they want to do together is to develop a production line for a 100% 3D printed UAV airframe. So the airframe components could be made in a production line. They hope then to get really customizable jets, so customers can then ask for certain kind of drone specifications and get them as quickly as possible. And they also then could quickly iterate and quickly adapt these UAV drones to the conditions of the battlefield or to kind of emerging situations. It's kind of a mass production paradigm, something we've talked about a lot in the drone swarms context for over 10 years now. And I think it's something we should watch because this could really change it. A lot of these drones are made by hand. A lot of stuff is hand lab, carbon fiber. A lot of stuff is very, very manual. And that means, and also the processes now are like the military in a long drawn out process orders 60 drones. And a couple of years later, they have new requirements and they do a new contest and they order another 50. And this could kind of like, I don't know if these guys are going to make it. They're both quite small companies. It's very innovative what they're doing. It's going to be really tough. But an idea like this to kind of in a mass production, mass customization way produce these drones is very, very compelling for the military. Think about like just being able to evolve your kit every day, make a better drone. And also think about being able to just, if you need 100 of them in the last minute, the supplier will be able to provide you 100 tomorrow. That kind of a mass customization kind of thing would be something that the governments would really, really want in the future. The next item is, well, it's something else. I apologize for the picture. I think this picture is like of some kind of Ken doll or something, and I don't know, it creeps me out. So really sorry about the picture. So the research behind it is very, very important though. Multi-thermal responsive double network composite hydrogel for 3D printing medical hydrogel masks. So the idea is to get a mass customized hydrogel mask. That's also something that for cosmetics, for wound healing, for burn victims could be really exciting. So you have a drug-loaded mask as well that is customizable to the patient, that is exactly the right size, and then can apply the drugs topically in a very concentrated way. Now, what they've done here is something really nifty. They've managed to drug load, essentially, the hydrogel with the relevant drugs at fridge temperature. Then they change the properties of the hydrogel at room temperature, and then they apply the hydrogel to the patient's face, and then at the body temperature of the patient, the hydrogel will start to act. So this kind of thing, you can call this a 4D printed item, or you could call us whatever you want, but it in effect is kind of more of a programmable material and a programmable thing. And you could easily see that in a clinical kind of setting, this could really kind of actually work. And I think something like this is really going to make a big, big difference in cosmetics and a lot of wound healing applications. Think of it just about how the idea of being able to produce this in a scalable, kind of less expensive way to really fit a patient's face and apply the drugs that they need exactly where they need them in the face as well. So this could be a boon for a lot of patients. So this was the news we have today, and apologies about the last picture. My name is Joris Peels, and this is another edition of 3D Printing News Unpeeled.